Hello, I'm Umur A Ciftci, and today we will explore privacy-enhancing deepfakes. My colleagues Gokturk and Ilke said, "My face, my choice," not wanting to appear on the slide, so I applied our approach to the photo instead of masking them with emojis. Face recognition has been one of the most interesting research topics in computer vision. However, some of the applications has been controversial because of malefacent motivations and lack of cyber laws around the digital identity. The public's reaction to everything that goes wrong about face recognition was to avoid online photos altogether. In many cases, avoiding social media is not even the answer. Each of us has hundreds of photos taken with or without consent. We can't control who has photos of us. Even WACV audience here, yes you, will post pictures of us online. Traditionally, approaches that break the continuity of the image or revertible linear operations are suggested as a defense mechanism. Moreover, deep approaches mostly lose gestures or emotions in the image. Our approach does not break the image or the context and misleads face recognition systems with fake faces, using deepfakes for good. To overcome these limitations, we present My Face, My Choice, empowering people to have control over their faces, where unauthorized face results in replacing the face with a dissimilar enough deepfake. The new faces are quantitatively dissimilar to the original face, are not similar to any other face, approximate the original age and gender, and preserve the original head pose and expression. My Face, My Choice is a novel privacy-enhancing anonymization system that builds on face access models. We believe that My Face, My Choice is the first approach to extensively utilize face embeddings to create useful deepfakes as an adversary to the face recognition. We designed the face access models as follows. 1. Disclosure by proxy that enables the uploader to decide on authorized faces. 2. Disclosure by explicit authorization that converts explicit tagging permissions to implicit deepfake directions. 3. Access rule-based disclosure that combines the social graph and group-based permissions to decide whether or not to replace the face. To select the target face, we need a comparison metric which yields similar enough faces for contextual and visual continuity, and dissimilar enough to confuse the face recognition systems. For all metrics, we experiment with minimizing and maximizing the embedding distance and normalizing these to age and gender vectors. Moreover, My Face, My Choice does not aim to create a new persona per person, thus we add the randomness within a threshold while selecting the targets. So every time you appear in an unwanted photo, your face is replaced by a different dissimilar face. As a real-world example, you can observe the closest, furthest, normalized, and randomly furthest target images, coupled with My Face, My Choice results per face and per the overall image. Following our motivation, we need to preserve the extinct attributes to be free of any pre-training, to effectively swap many faces with no artifacts, and to significantly change the identity. To satisfy all these conditions, we use SimSwap, which is a traditional deepfake method with an ID injection module and weak feature matching for facial attributes. As we sample in our results, My Face, My Choice works with different populations, different image content, and different environmental conditions. We also evaluate our results in terms of how much My Face, My Choice can trick face recognition algorithms. Evaluating on 7 state-of-art face recognition tools, My Face, My Choice reduced their accuracy by 61% on the average and 65% if we lift the randomness. Source target recognition validates our target query formulation, and source result recognition validates our results. In order to find the best deepfake generated, we evaluate 4 models in 6 different spaces and conclude that SimSwap quantitatively and visually the best. In our work, we experiment with a randomly generated and a balanced dataset for a target query set. Resulting distributions are more similar in terms of embedding distances, which reflects that My Face, My Choice is not affected by different dataset for target queries. Thanks for attending my talk and hope to see you in WACV if you choose to.